0.5, they could probably have just combined these two sections. I'm going to kind of do the same thing, sort of. So what we're going to look at, just to begin with today, is rational functions. We have talked about those before. We just haven't talked about the graphing and that kind of thing like that. We've talked about domain and stuff, though. Okay. So what a rational function is it's just a ratio of polynomials. Okay. So I'm going to use r of x for a rational function. Just the numerator and denominator are polynomials, and then the denominator, can't be 0. So that's why I say q of x can't be 0, because you can't divide by 0. First thing we're going to start on is, we'll kind of get through the domain and the asymptotes today, I think. So we've already talked about the domain of a rational function. And it's always the same. On a rational function, if you want to find the domain, what do you do to the denominator? You set it to 0 and solve, and it will be everything except what makes the denominator 0. A lot of times you can do this in your head. So you just set that equal to 0, solve the equation. So x can't be -4, okay? So a lot of these domains, some of these we're just going to write in set builder notation. So if you say set builder, all I really need you to do is say set of x, and then just say x is not equal to -4, and that's good enough. But what you're saying by that is it's everything except -4. You don't have to say it's all real numbers except -4, but technically that's what that is, okay? All right, next one, you do exactly the same thing. You don't even worry about the numerator on domain. That has nothing to do with anything. So you just take x squared minus 1 equals 0, solve that equation. If you can do that in your head, you do it in your head. So this one I'm going to do square root property on. You could also factor. So I square root both sides. So I'd get x plus minus 1. So it means in this problem, x can be anything except plus minus 1. I do want to show you something about this problem too here in just a minute. So we would just say set of x, x not equal, and you can say plus minus 1 if you want to. I know my math lab may not let you do that. You may have to say x not equal to -1, comma, x not equal to 1, like that, okay? So I want to show you one thing on this problem. If you took this expression and if you factored the denominator factors as x plus 1, x minus 1. A common mistake students make on this problem a lot of times is cancel that out and then just say the domain is x can't be 1. That's not true. Okay, don't worry about that canceling out. This original function is undefined at -1 and 1. So don't do that when you're asked for domain. It's a different thing if you're asking for what we call vertical asymptotes. But domain, you don't even pay the slightest bit of attention to the numerator. Okay, so let's do the next two here. All right, so this one, same idea. We're just going to set the denominator equal to 0. This one will factor, I'm pretty sure. If it doesn't factor, you'd probably go the quadratic formula. So usually I just show students how to do this by trial and error. So the first term would be 2x and x. The last term would be 3 and 1. The order is going to make a difference on this. So let's try like a 1 and 3 like that. It's only going to work one way if it works at all. So that would be a 1x. That would be a 6x. And we're trying to make 1 and 6 add up to -5. So you can do that. Okay, if the 1 is negative, a positive, and the 6 is negative, then it adds up the way it's supposed to. So it looks like we would have plus minus like that. If you did the 3 and 1 the other way, it wouldn't work. It may look like it would work, but it wouldn't. You would never get it to work. So that would be your factoring on that. And then what you do is you just set each factor equal to 0 and solve, and then the domain will be everything except these two numbers right there. Okay? So with this, I can move the 1 to the other side to get 2x equals -1. Divide by 2, so I have -1/2 is one number that causes the denominator to be 0. Same thing over here, which you can do in your head. That gives x equals 3. So what we'll do on the domain on this is just write these in set builder. We'll say set of x, and we say x is not equal to, and you can just use a comma if you want to. I don't mind if you do that like that. So that would be your domain. Okay? All right, so all those problems are the same thing. It's just focusing on what makes the denominator equal to 0. Okay? All right, the next one. Let's take a look at what happens on this next one here. Okay, let's again do the same thing. Just set that equal to 0 and solve that equation. Now, this equation, it does not factor. You have to use the square root property on this, so you would have to subtract 4 from both sides. So you get x squared equals -4. Okay? Now, what happens when I do square root of both sides? What do you end up with? An imaginary number, right? You end up with plus minus 2i. So you're not going to say x is not equal to plus minus 2i, because when we're talking about a domain, we're talking about real numbers anyway. So what this means then is all real numbers is the domain. Okay? Another way to look at this problem is like this. Okay, if you have x squared plus 4 equals 0, just think of it this way. If you square a number, you're going to get a positive number there, right? Regardless, if you square something, you're either going to get 0 or positive. Can you ever square a number, add 4 to it, and get 0 with a real number? No. If you square a number, it's 0 or positive, right? That plus 4 is positive, so it's impossible to find a real number that will make that denominator 0. Okay, the math bails you out of that. You got two complex numbers, that means every real number works. We don't worry about complex numbers. Okay, that's the idea. Okay, so that's kind of what happens on those issues. The next thing I want to run through here today, I think we'll just focus on the vertical asymptotes and kind of show you what happens on these. And we'll do a couple of these with a calculator also to kind of help you understand what these things are. So what you do, a vertical asymptote is going to be where the reduced form, and that's real important, the reduced form is undefined. Okay? So you do factor and try to reduce before you find a vertical asymptote. So on these problems, it's going to look like I'm doing just about the same thing I did on the last page. This one is already reduced. So what we're going to do is set the denominator equal to 0, and then solve that equation, and that will give you the equation of what we call a vertical asymptote. Okay, so that's going to give 2x equals -3. Then you can divide by 2. So you get x equals -3/2. So that's called a vertical asymptote. I want to show you something on your calculator. Get your calculator out and do this along with me if you would. It kind of depends on your background how much of this you've done in the past. So you have to put this in like this. You go to y1 and you do 1 divided by, now you have to put parentheses. Anytime the numerator or denominator has more than one term, you got to put it in parentheses. So we'll just go 1 over 2x plus 3. And then just do that in a standard window. So you can go zoom 6 like this. So I want to show you what happens. When x is equal to -3/2, there's a break in the graph. So what's going to happen is a vertical asymptote, there's going to be a break, and the graph is either going to go to infinity or -infinity as you get close to it, like that. Okay? So I want to show you something on this also, and you can do this along with me. That's -1.5. So if I traced at something like -1.4, that's a little bit bigger than -1.5. Notice what happens. You get a positive number. And what's going to happen is as you close in closer to that, like if you did -1.49, then look what happens. And you get 50. So the closer you get to that asymptote, the higher the graph goes. That's what happens on that. And the reason is because you're really taking 1 divided by a number that's getting close to 0. Okay? What you have to understand about an asymptote basically is this. You know that you can't divide by 0, but if you do this, if you take 1 divided by a number close to 0, then what's going to happen is it's either going to go to infinity or -infinity. So that's a number close to 0. Notice that it gets real big. And that's what happens around an asymptote is you're just dividing by a number very close to 0. That's why the graph goes to infinity or -infinity. That's the idea. Okay? All right, so that's how you find a vertical asymptote. Let's do the next one here. And finish this up. So again, you want to factor and see if anything reduces. Okay, so if we factor the denominator, we'd have x and x. You would have 3 times 2 to get 6. And then you would have a minus and a plus if you factored that correctly. Nothing cancels out. So that means if nothing cancels out, then what you want to do is you just set each factor equal to 0. And then you solve. And that'll give you 2 vertical asymptotes on this problem. So what you would have is x equals 3. And then you would have x equals negative 2. Okay? Let me show you what this one does on the calculator. Put this one in the calculator also. And again, this one you got to put the numerator in parentheses. Okay, because there's more than one term. And then you divide by, and then you put the denominator in, which is x squared minus x minus 6. So just so that you see kind of what this graph looks like. You'll find 2 breaks in it. So you'll find a break at negative 2 and a break at 3. And that's what the graph of rational functions typically look like. When they have vertical asymptote, there's a break and the graph goes one of the 2 directions. It always will. That's the idea. Okay? All right, let's finish up, I think, with this example 3. And this thing right here does not factor. So there's nothing you can reduce on this or anything. So what you do, I think we did a problem like this before. So you set the denominator equal to 0. If you do that, you would get x squared equals negative 9. If you do that, you would get x equals plus minus 3i. Now, what would that tell you about a vertical asymptote? What do you think? There are none, exactly, okay? That's because it's imaginary. So if you actually put this in your calculator, you're not going to see any asymptotes on this. I'm going to put this in here real quick just to show you what I mean. Okay, and again, the bottom doesn't factor. So if you did this, x plus 3, and then x squared plus 9, if I do that in the standard window, you're not going to see any asymptote popping up. Okay, you'll just kind of see something kind of going like that. So there isn't an asymptote because there's no real number that makes the denominator 0. Okay? All right, so that wraps up today. We'll finish this up next time and probably get into the next couple sections. I'll just print out the next couple sections because it takes me a long time to put these together anyway.